In this lesson, we're going to talk about injection attacks. We're going to focus on SQL injection attacks, LDAP, XML, and command injection attacks, and a variation called the directory traversal attack. A lightweight directory access protocol, or LDAP injection attack, is used to exploit a web-based application. If the application fails to properly validate the input in the form fields, then it's possible for the wrong commands to be constructed. This could potentially provide an attacker with unauthorized access to the LDAP directory tree. They may be able to view more information than they should, have access to it, or even modify it. Suppose we have an application that uses LDAP calls to communicate with the directory tree. Client workstations can access the web server, load the application's web page, and query the directory services tree. Here, if the user supplies an invalid value or a malicious value, unexpected behavior can occur. For example, suppose the user puts in an asterisk in this field and submits the form. Depending on the configuration, the directory server could respond to the LDAP query with a list of every user in the directory services tree. You do not want an attacker to be able to see all the users in your tree. An attacker could even use this field to view the attributes of a user object, such as the password. An XML injection attack manipulates the XML structure used by an XML-based application or service. It inserts malicious content into the structure, which can affect the application's output. An XML injection attack might cause your C data field to be ignored by your XML parser and input validation filters. It'll slip by. In this example, the payload contains a malicious URL. If the user clicks on the link thinking it's for something else, it will actually go to that user's banking account and run a cross-site request forgery attack. This is just a simple example, and the result of the attack would depend on what the malicious URL contains. Let's review command injection attacks. The purpose of this attack is to inject and execute commands in a vulnerable application. The vulnerable application runs commands on behalf of the attacker with the privileges assigned to the application itself. Let's suppose a Linux server is running the DNS service. If an attacker was able to exploit this service, they could then run commands on this Linux server. This was a very popular attack several years ago. Many system administrators ran this service as the root user account, which allowed them to run commands with full access. To combat this attack, you should never run a service as an administrative user. Instead, create a limited user account on the system that only has access to what the service requires and nothing more. Let's look at one more variation of the injection attack called the directory traversal attack or path traversal attack. This attack's goal is to gain access to a specific file stored elsewhere in the file system. It usually exploits some type of vulnerability in the application itself, such as not properly validating user input. In this case, characters representing the path to the parent directory on the application server could be manipulated to allow access to secure files. For example, let's say there is a file directory with two subdirectories. Inside subdirectory A, there's a file named 123. Inside subdirectory B, there's a file named 456. The user, in this case, only has access to file 456, and he can search the directory hierarchy for a vulnerability and access file 123. Because of this vulnerability, web applications need to be coded such that they look for all characters that could be used for directory traversal, whether it's the actual characters or their percent encoded equivalents. SQL injection attacks are powerful and complex. They're the tool behind many successful high-profile internet security breaches. In 2011, Sony was targeted by a SQL injection attack that compromised over 1 million emails, usernames, and passwords. In 2013, the United States Department of Energy was targeted, and at least 100,000 employee records were compromised. Perhaps the most ironic attack occurred when MySQL.com was attacked, releasing a large list of usernames and passwords to hackers. In each of these instances, the vulnerability wasn't in the SQL software, but in the way the websites and applications were implemented. Each of these attacks could have been prevented with careful front-end configuration and penetration testing. Because the SQL injection attacks target web applications, let's review how they work. When a user connects to a web application, they make a request through the browser. This request travels over the internet and to the web server. The web server accepts the request and sends it to the corresponding web app. The web application accesses the database, completes the requested task, and then responds to the web server. Once the transaction is complete, the web server sends the requested information to the user's browser. Because attackers are seeking information stored in the database, we also need to review how those work. A database is typically described by the way it stores data. A relational database can be organized in different ways depending on need. For example, customer orders can be sorted by customer number, zip code, or product number. A distributed database is designed so it's easy to replicate to various locations across a network. An object-oriented database is designed around object classes and subclasses. Inside these databases are various methods used to organize, manage, and retrieve data. Records and rows are used to represent a collection of relative data, such as information about a product, a user, or a customer. Think about the times you've gone shopping online and you've sorted your selection by color, cost, or rating. These filters are possible because of these databases. SQL was specifically designed to request data from a database. These requests take the form of a query, a question, that asks the database to provide information specific to your request. It's important to note that SQL injections are a result of flaws in web applications, not in the database or the web server. These attacks exploit non-validated input vulnerabilities and use them to send SQL commands through the web application and to the database. This is done by injecting a code into an existing line of code before sending it on to the database for execution. If the injection is successful, the malicious code runs on the backend database and returns the requested information. So, how does a SQL injection work? Let's start with a very basic example. Let's say you're logging into your account. Normally, the user will enter their username, Bob Smith, and their password, secret, into the appropriate spaces. Once they click submit, the web application will send a string to the web server that contains the credentials. The command tells the database to check for the provided username and compare it to the stored password before granting access. Assuming that the user is found, they're directed to the requested page. As you can see, the data that the user entered is put into the same query as the commands. As a result, this code is susceptible to SQL injection attacks. If the login fields haven't been restricted, an attacker can add anything they want to them. Let's say the attacker knows that Bob's username is Bob Smith, but they don't know Bob's password. They may be able to enter Bob Smith in the username field. The single quote indicates that data has ended and a command is beginning. The double dashes indicate that code is ending and a comment is being entered. Comments are code that a program doesn't execute. They usually contain explanations or reminders for the programmer. Because of this, the application knows to ignore the comments. Now, because the command treats everything after the dashes as comments, the instruction to verify the username with a given password is no longer visible, and the user is granted access to the user account. Although it's fairly easy to detect the initial vulnerabilities for this attack, SQL injections are extremely complex. They require a lot of patience and a high level of database and coding expertise. So why would attackers go to all this trouble? Well, with great effort comes great reward, and that's what these attackers are counting on. SQL injections can be used to implement several types of attacks. When an attacker attempts an authentication bypass, they log into an application with administrative privileges without having to give a valid username or password. An information disclosure attack provides an attacker with sensitive information from the database. An attacker can use a compromised data integrity attack to deface a web page or alter a database's contents. Attackers can use a SQL injection attack to compromise data's availability. In other words, they can use it to delete information stored in the database. Attackers can also use this type of attack to remotely execute code and compromise the host operating system.